Okay, if you got this kind of function, remember this curve because you will see it a lot in calculus. This is a graph of 1 over x squared. Function 1, it's rational function, 1 over x squared. If you want to define domain and range, if you track the domain coming from negative infinity, so you see, always look at x-axis when you describe domain. And then you move along the curve, you'll see that here, this is the point, -3, -2, you see -1, continue, and then you're gonna come closer and closer and closer to 0. Then once you come closer to 0, the point will jump over the infinity and then go down again. Go down again to the positive part, a half, 1, and then continue 2, and then continue 3, 4, 5, 6,000 million. And the conclusion of that if you look at the domain, you will see that the domain exists in all x values except 0. All x values except 0. Here is, it's a kind of gap you have. It's over here, a gap around 0. 0 doesn't exist in our domain. So how to do that? Say domain, write it as the following: all real numbers except 0. Different type of writing to the domain. You could describe it as all real numbers except 0, or you could say x doesn't equal 0. Now, if you track range, you will see that you will never reach the value 0 over here. But going with the curve from this side, you will see 1, 2, 3, 4, 5, 6 million on y-axis. And from that side too, from left side, you will see not 0. You will never ever see 0. 0 is opened. We call this later, it's asymptote, horizontal asymptote. Then you go with 1, 2, 3, 4, 5, 6, 7 million, infinity. The conclusion that y is greater than 0 never equals 0, but we could say y is greater than 0, or sometimes they describe it as from 0 to infinity, open 0, we don't include 0, and open infinity. That's our range. Also look at this function. It's very important. You will see this function in calculus. Especially we have the limit will be in the second chapter. That's for y equals 1 over x. So this is for y equals 1 over x, and this is for y equals 1 over x squared. Still odd in here, still even in here, even function. And you will see that the domain never includes 0, never have 0. It's a crazy line. If you move along x-axis, you will be coming from negative infinity, and then you will see a lot of points, million, thousand, 100, 10, 5, 1, 1.1, 1.2 over here. That's you tracking. Look at this. Back, back. That's the projection, X projection in yellow. Continue, 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 continue. Once you come closer to 0, so the curve almost gonna touch 0. That's down in negative infinity. Then crazy, it will jump to the heaven. So from hell to heaven over here, up to the sky with positive infinity, up and up and up and up. So you're gonna move along this curve, and then you track the domain. There's never be 0 over here. You track the domain. You track the domain. in yellow. You drag the domain in yellow. 1 point something, 2, 3, continue to infinity. So it's from negative infinity to positive infinity except 0. That's the domain. Range is the same, from negative infinity to positive infinity except 0. We could note it as domain x doesn't equal 0, range y doesn't equal 0.